All right, Year 12, some students have asked about exercise 106, questions 12 through to 17, 19. Remember, we don't do any of the extension questions. So this carries on from the sum of infinite series. So remember, S of infinity equals A on 1 minus R. But we still have to use our knowledge of T of n, which is a to the n minus 1, and S of n, and depending on which one you're going to use, a to the n minus 1 on 1 r minus 1, or S of n equals a 1 minus r to the n on 1 minus r. They're essentially the same formula. You don't really need to know two, but they give you two in the on the formula sheet. So if we have a look here, question 12, a geometric series has a second term of 2/3 and a fourth term of 8 on 27. Well, I'm going to show you how to do this algebraically, but it's sometimes good to remember that this is a series. So term 1, our A term, is there. The second term is 2/3. Then there's a third term, and then there's a fourth term. So you've got to multiply by something and then multiply by the same something to get that. So you could go, 2/3 times R, because it's a common ratio, times R equals 8 on 27. That's how you get that term. So now 2/3 R squared equals 8 on 27. And if you go, so I'm going to multiply the 3 across and divide by the 2. So R squared equals 3 on 2 times 8 on 27. Now, 3 goes into itself once and into 27 9 times. 2 goes into itself once and into 8 4 times. So R squared equals 4 on 9. So R equals plus or minus 2/3. So we can have either of those. So we're going to get two answers for this. And once I've got R, to find A, I just go, well, here's the second term. So if I just divide by 2/3, so A equals 2/3 divided by 2/3, I'll multiply by reciprocal, 2/3 times 3 on 2, or A equals 1. Or A equals 2/3 divided by negative 2/3, which gives me 2/3 times 3 on 2, negative 1. So there are two possibilities for that. Now that's just thinking about it intuitively. But what I'm going to do is I'm going to do it the way that I think most of you will be interpreting it. And by the way, once you've got A and R, you can work out the sum of the series. But now I'm going to do it using the algebra. So T of n, we already know that, we wrote that up there. So T of 2 equals A R to the 1, and T of 4 equals A R to the 3. But A R to the 1 and T of 2 is 2/3, and A R to the 3 equals 8 on 27. Now I've got two equations with two variables. So I'm going to call this equation number 1 and I'll call equation number 2. But I'm going to change this one around. I'm going to write this one as A equals 2, 3. I'm going to divide that R across. And I'm going to substitute this equation. I'm going to sub 3 into equation number 2. So where there is an A, I'm going to put this. And watch what happens. So therefore, I get 2/3 on R cubed equals 8 on 27. Oh, it's looking remarkably similar to what we did before. So we get 2R squared on 3 equals 8 on 27. We'll multiply the 3 across and divide by the 2. R squared, and we already know that that is 4 on 9. And we'll square root those, and we'll get plus or minus 2/3. And once we've got plus or minus 2/3, we again plug that into into either of these formulas. So we'll plug it in here to equation number 3. So sub R equals 2/3 into 3, and we get 2/3 on 2/3. Oh, what do you do when you divide by a fraction? So that's what A equals. You multiply by the reciprocal. A equals 2/3 times 3 on 2, which equals 1. And if we sub R equals negative 2/3 into 3, we get A equals 2/3 on negative 2/3. Better put a times in there so we know what we're doing. So you multiply by the reciprocal, so 2/3 times negative 3 on 2 equals negative 1. Therefore, S of infinity equals A 2/3, 1 on 1 minus 2/3, which equals 1 on 1/3, which equals 3. You do that on your calculator. Or S of infinity equals 1 on 1 minus 2/3 negative. God, that's ugly. I'm just going to tidy that up. Which gives me 1 and 5 on 3. Because 1, that's going to be 3. 3 minus 1, yep. Multiply by the reciprocal, 3/5. So, why is that negative? It's meant to be negative 3/5. It's meant to be negative 3/5. Oh, A is negative 1. That's why. There we go. All right. So, our options are A equals 1, R equals 2/3, and S of infinity equals 3. Or A equals negative 1, R equals negative 2/3, and S of infinity equals 3 on 5. But remember, if you can think about it a little bit intuitively, you can avoid having to do all that. You can get the R straight away. So try and remember what it is you're doing, what you have. It's a series that you're just finding what you multiply by each time to get it. So I'm just going to do the next one intuitively. You can do it algebraically, and then I'll do 14 algebraically. And then by then you should be able to do 15 and, well, I'll do 16 and 17. So 13. So here's question 13. So I've got the first term. Could call it A. I got the second term. Let's use algebra. So I've got A, AR, and then the third term is 54. Then I've got the fifth term, so I times by R. Then I get, the fourth term. Then the fifth term, I times by R again. And the sixth term, I times by R again, is 11 and 83 on 125. So 54 times R cubed equals this 11 and 83 on 125. So I'm going to pump my calculator up and I'm going to go R cubed equals 11 and 83 on 125 divided by 54. And I'm going to want that answer as an improper fraction because I'm going to cube root it and I know it's going to come out to a fraction. So 11 and 83 on 125 divided by 54. So I get 27 on 125, and I'm feeling pretty good now because I know the cube root of 27 and I know the cube root of 125. So if I cube root that, I'm going to do it on my calculator, but I know it's going to be 3 over 5. And there's only one answer because there's only one when you get a cube root. So 3 over 5. And if you go back to your calculator and you cube root your answer, you get 3 over 5. So see how I thought about that intuitively? I've got this term, which is the third term. To get the fourth term, I times by R. The fifth term, I times by R. The sixth term, I times by R again. So 54 R cubed equals 11 and 83 on 125. And if you can think about it like that, you're away. Now, to get my first term, well, I know that the third term is 54. So to get the second term, I divide by 3 on 5. And to get the first term, I divide by 3 on 5 again. So I just go, 54 divided by 3, I'll write it as divided by 3 on 5. And I'm going to, and divide by 3 on 5 again. I could have done 3 on 5 squared. You get 150. So the first term, so divide by 3 on 5 and divide by 3 on 5. So the first term, A, equals, what was it, 150? 150. So therefore, the limiting sum, S of infinity, and there's only one of each of these, is A, 150 on 1 minus 3 on 5, which is 150 on 2 on 5. I'm just going to do that on my calculator. 150 divided by 2 on 5. 375. And I'm just going to check the answers. Yep, 375. Now, I'm going to do one more, but I am going to do this one algebraically because I know some of you would prefer to think of it that way. So I'm going to use my T of n, my S of infinity, and I'm going to get equations and I'm going to solve them. So 14. So the second term, T of 2, equals 4 on 15. Now T of 2 is AR to the 1. So AR equals 4 on 15. The fifth term, T of 5, equals 32 on 405. 32 on 405. which is AR to the 4 equals 32 on 405. Well, again, I'm going to call this equation 1 and I'm going to call this equation 2. And I'm just going to sub 1 into 2. Now, I'm just going to rewrite 2 a little bit. It's AR cubed equals 32 on 405. So now I can just put this in for that. So 4 on 15 R cubed equals 32 on 405. So I'm now going to multiply the 15 across and divide by the 4. So R cubed equals 32 on 405 times, I'm going to divide by the 4 and multiply by the 15. And you can go to your calculator, but you get 16. I'm going to have to use my calculator, but I'm pretty sure it's going to be 105. 405 divided by 15. 27. 27. So R cubed equals 16. 4 doesn't go into 32 16 times. It goes into it 8 times. Should have used my calculator. 8 on 27. And I'm lucky because I know the cube root of 8 is 2 and the cube root of 27 is 3. And there's only one answer because it's a cubed answer, so R equals 2/3. Now, how do I find A? Well, I can just divide this term by 2/3. But I know some of you are going to want to use a formula, so remember up there I had AR equals 4 on 15, which is equation number 1. So I'm going to sub R equals 2/3 into equation number 1, and I'm going to get A times 2/3 equals 4 on 15. So to find A, which we already knew intuitively, was to go 4 on 15 divided by 2/3, and that's exactly what we're going to do. We're going to divide by the 2 and multiply by the 3. So A equals 4 on 15 times 3 on 2, and that's going to be the 2 and 2/5. So now I've got my A. Yeah, that's hard. Now I've got my A and my R, so all I have to do is find S of infinity. S of infinity equals A on 1 minus R. So that gives us 2/5 on 1 minus 2/3, which is 2/5 on 1/3. What do you do when you divide by a fraction? You multiply by a reciprocal. 2/5 times 3 on 1, which is 6 on 5, which is 1 1/5, which is the correct answer. So that's algebraically, or you can do it intuitively. I wasn't going to do 15. I want you to go and have a go at it, but I am going to do it because I know some of you might be struggling with this. And try it, go and try it yourself, and then come back and see how you went. See if you did it a different way. So question 15. The limiting sum of a series is 5. Second term is that. Find the first term. So I'm just going to write my information. So 15. I don't know what A is. That's what I've got to find. But I know that S of infinity equals 5. So A on 1 minus R equals 5. I also know that T of 2 equals, is that 1 1/5? 1 1/5. 1 1/5. I prefer it as a whole, as a fraction, so 6 on 5. But I also know that that's AR. So why don't I just substitute one into the other? And the easiest thing is going to rewrite this as go A equals 5, 1 minus R. I multiply that 1 by, and A equals 5 minus 5R. I'm going to call this equation number 1. I'm going to call this equation number 2. And I'm going to sub 1 into 2. And I'm going to get, so I'm going to put this where the A is. So I'm going to get, in brackets, 5 minus 5R times R equals 6 on 5. And all of a sudden you're thinking to yourself, oh, I'm going to get a quadratic. Yes, you are. That's okay. You're not worried about quadratics. You know how to solve them. So immediately you're going, 2 answers here. So here I get 5R minus 5R squared equals 6 on 5. I'm going to multiply that 5 across, so 25R minus 25R squared equals 6. I'm going to take everything over the other side, or, just multiply by 25R squared minus 25R. If I take it over, plus 6 equals 0. So this is going to be hard. I wonder if I'm going to have to use a quadratic formula. What are we doing? 15. Is this 15? I'm a bit worried because there's only one answer. Oh, no, there are 2. Righto. So, 25 times 6, 150. What multiplies out to 150 and adds up to 25? I reckon it's going to be, 5 and something. 150 divided by 5. 5 and 30, no. 150, 10 and 15, you peanut. All right, so 25R squared minus 10R plus minus 15R plus 6 equals 0. So take 5 out of that. We get 5R outside of 5R minus 2. And I'll take 3 out of this. And I get 5R minus 2. So I get 5R minus 2, or 5R minus 3 equals 0. So I get R equals 2/5, or R equals 3/5. Now, way back here, I've got A equals 5 minus 5R. So I'm going to sub these into 1, and it was 5 minus 5R. So remember, A equals 5 minus 5R. So A equals 5 minus 5 times 2 on 5, which is 5 minus 2, which is 3. Or A equals 5 minus 5 times 3 on 5, which is 5 minus 3, which means A equals 2. So A equals 3, R equals 2/5, or A equals 2, R equals 3/5. Let's just check that as an answer. There we go. Now, I'll do 16 and 17, but I really want you to go and have a go at them. So I'm only doing these if you really can't do them. Make sure you're having a go. And remember, there are work solutions. So I'm just going to create some space here. And again, I'll probably do this one algebraically. I don't know if I can do it intuitively like I did some of the earlier ones. And even if you do it intuitively, you've got to show what you're doing so that a marker can go, oh, that person knows what a geometric series is and how to get the terms. So, 16. What do we got? A equals x. Oh, look at that, straight away. Didn't even put my equal sign in. Equals x. And r equals x on 4 divided by x. Well, that means x on 4 times 1 on x, which is a quarter. And that you can look at it and see there. So, s of infinity equals a on 1 minus r. Well, we're told that s of infinity is 7 on 8. Now a equals x, and that's 1 minus a quarter. Well, 7 on 8 equals x on 3/4. Now you've got an option here. You can just multiply the other side by 3/4. Multiply that 3/4 across. It's a number. Imagine if it was a decimal. It was 0.75. You just multiply it across. So 7 on 8 times 3/4, and that gives you 21 on 32, which is the answer. Now, 16. 17. So if you just set it out logically, solve the equations, you should be right with most of these. So 17. And remember, you've got to try them yourself first. Don't just sit here and wait for me to do it. Plus, you might find an easier way to do it. 17. For what values of k does the limiting sum exist? Okay, so a equals k. R equals k squared on k, which is k. Well, for a limiting sum, r, the absolute value, must be less than 1. And r equals k, therefore, the absolute value of k must be less than 1. Find the limiting sum when k equals negative 2/3. Well, we already know that'll be a limiting sum. So that's part 1. Part 2, or A and B. Well, that means A equals negative 2/3 and R equals negative 2/3, because they said find the limiting sum when K is negative 2/3. So the limiting sum is negative 2/3 on 1 minus negative 2/3. Well, that's negative 2/3. And I do this on your calculator. All right, this 1 minus 2/3 on your calculator. So I'll do it just so, but I know it's going to be 5 on 3. But let's do it. 1 minus negative 2 on 3. 5 on 3. Always good to check. Multiply by the reciprocal, negative 2/3 times 3 on 5. The 3's will cancel, which gives me negative 2/5. Now, C. Evaluate K if the limiting sum of the series is 3. So, here's C. S of infinity equals A on 1 minus R. So 3 equals, now here, look, A is K and R is K. So you're going to get K on 1 minus K. Oh, that's 3 outside of, multiply that 1 minus K across equals K. And I'll expand that. So I get 3 minus 3K equals K. Add the 3K back, 3 equals 4K. And divide by the 4, 3/4 equals K. So that's 17. You go away and have a go at 18. I'm going to create some space and I'm going to do it. No, we don't have to do 18. 19. Show that any geometric series, the difference between the limiting sum and the sum of n terms is that. Okay, well that's just going to be playing with the formula. So I'll create some space. And this is the last question. And I'm sure that there's a good proof of this in the work solutions. So let's set it up. Show that any geometric series, the difference between the limiting sum and the sum of n terms is. So 19. S of infinity is A on 1 minus R. S of n is A R to the n. Oh no, tell you what I'm going to use. I'm going to use the other form because it's going to have the same denominator. And I'm going to be able to do it rather than having 1 minus R. So I'm using this formula, and that's when R is less than, because remember, for this to be true, R, absolute value of R is going to be less than 1. So I'm going to go S of n minus S of infinity. Well, that's A 1 minus R to the n on 1 minus R minus A 1 minus R. They have a common denominator, but I'm going to expand the first here. A minus AR to the n on 1 minus R minus A 1 minus R. Okay, so that's A minus AR to the n minus A over 1 minus R. Well, A minus A will go, leaving me with minus A R to the n over 1 minus R. What do we have to prove? Now, why have I got a not a negative there? It's my 1 minus R around the right way. if I did the subtraction the other way, I would get it. Did I do it the right way around? Show that in here, so the difference between the limit, yes, I subtracted them the wrong way round. So s of infinity minus s of n, and you can see what's going to happen. A 1 minus r to the n minus a, oh, sorry, I've done exactly the same thing. A on 1 minus r minus a 1 minus r to the n on 1 minus r, which gives me a on 1 minus r minus a r to the n on 1 minus r equals a minus a 1 minus r. But remember, fire out those trucks. Remember, here I've got a minus minus, so this will become plus a r to the n, which gives me a r to the n on 1 minus r. I got this result by subtracting the wrong way round, but that's okay, because when I subtract, and if I do it the wrong way around, I should get the same value, just a negative sign. So there's that one. All right, good luck.